Hi again. Okay, let's do something useful now. We're actually going to look at these data sets and count and get some numbers out. We're going to count these 4 HeLa cells here. You may want to do it with a bigger number of cells and whatever you want to do, but the principles are the same. And so we're going to try and count the 4 in the middle and get the area, let's say, or the intensity as well, maybe. And then afterwards we're going to come back and try and distinguish where the cells are and look at the body of the cells. And where they touch. But for today, it will just do the nuclei. So we'll change this into color and just look at our blue channel here. And actually, before that, let's just quickly note about the turn off the green, and we'll just look at the Z-stack. The nuclei are often a little higher than the cell adhesions on the glass, and so if you have a few different Z-stacks, you can take a few different Z's, and then you can project. If you have larger Z-stacks and more information in the Z, you may want to go to Analyse and do 3D analysis. For basic 2D analysis, you can use the Z and project it down into a flat image, and we can use image, stacks, Z project, and we use the max intensity. And then it's just going to project that down, and we're going to change these values a little bit, so we need to change the contrast, and we'll hide that one for now. And we just want to look at the blue, so let's go to color and look at the blue, and I'm going to duplicate that channel out, Control Shift and D. Just do the channel we've got, so we'll turn that checkbox off, and we'll call it not blue, let's call it DNA. Sorry, DNA, right. Okay, and so now we've got just that channel and just the data, and I'm going to change the lookup table to LUT to greys, because the eyes do a lot better on greys. You should always deal with the grayscale when you can. Blues are less bright to our eyes, so we're less sensitive to that. Most sensitive to the green, so we see it a lot better. So it can be misleading. So always work with the grayscale and then do the color for the overlay. And so we can distinguish the nuclei based on their size and their intensity and their shape. We have some other little spots of random miscellaneous labeling here that we don't want to include, so let's just look at the data. We'll grab our line tool and we'll put a line straight through there, and go for Analyze and Plot Profile. It's nice to see the data, and this is the only really way we can actually see what the values are. If we pick out one section, the picture itself on the screen is only telling us part of the story. The screen values, just as a side point I normally talk about with people, is this only goes from 0 to 255, whereas the data sets in this particular case goes up to 4,000. So you're never going to see all of the colors and all of the values on the screen, and this line plot will show you a much better way of looking at that. You can see the background is down here in a couple of hundreds, and it's easy to distinguish the nuclei based on its intensity. And we'll have to get rid of these small ones right here because of they'll be included, but we can get rid of them based on size. Okay, so let's kill that, and we'll click on the window to get rid of it, or don't forget the selection menu is here, and you can select none. And so what we're going to do now is do a threshold. So image, adjust, threshold, and wherever you place this slider is what it includes in the data set. This dark background might be checked, and that will be inverted. This is if you've got DIC or something else, and for normal fluorescence you want that checked. Also, if you're not using the grayscale and you're just going straight with the color, sometimes the red channel is a little bit hard with this red overlay for the threshold area, and you can use one of these options here just to display it in a different way. So we'll pick a value, and you have to make sure you have a complete enclosed external kind of boundary on these. If you end up with something like this, you'll end up not quite catching it, and if there are some cuts in it like that, maybe it's going to jump in and not quite give you the right analysis. So I'm going to back up a step and reset this and get rid of that threshold, kill that little window. And also, if you get stuck with the threshold you can't get rid of, you can go to overlay and remove overlay, because the threshold lives in the overlay level. I'm going to smooth the layer out a bit, and that's why I duplicate, so you can do a little bit of smoothing. You may not need this, but if you go to median, for example, you can get a preview and you can see what it looks like when you smooth it out. We can do 2, even more, just extreme case to show 5, and you can still see the outline, but it's a much cleaner outline, and so you can use these smoothing factors to get rid of these things. Too much, you start to change the information, but a small amount, a couple of pixels is fine. Let's go with 2, and then should we do threshold again, Control Shift and T. Now we can see that we get the threshold of that other one there a lot easier, and that can be useful. It's not as necessary in this case, but it can be useful when the data is a little fuzzy, to get rid of those. Okay, so there's our threshold. I'm not going to hit apply. That's going to turn it into a mask, and we don't necessarily need to do that. We can, but that's leads into binary operations and things, and we'll leave that for now. So we'll leave the threshold in place. The options in Analyze is just to measure, but before you measure, you can double check what it's going to measure, and there's a set measurements option here. Right now we've just got area clicked, but you can pick all the other options and whatever you want, and help gives you a good breakdown of those. And these we'll remember for each machine. So if I select these now and close and come back to it another day, it will be the same settings, and you can change it for each analysis you want. But this is, you kind of do it once and then forget about it until you do something else. And then so if I were just to click on measure, I get the area of 81,000, which seems a little neat. And with just like the wet lab, and you have to do controls in the analysis as well, just to convince yourself of what you're seeing. And so it's not actually measuring the threshold yet. So in order to measure that threshold, we'd have to go to selection and create selection from the threshold. Right, so that's got that yellow line, which is our selection now. And now if I do measure, I now get something more, you know, what you expect, not quite so neat. And that's the area of my selection, which is all of it in one. But we want to split them out and count them and get area per nuclei, things like that. So we're going to get rid of that selection. So let's select none. If we go to Analyze, and we can use Analyze particles, we can have some breakdown on sizes and shapes and things like that, and how to display things. So the size we want, it's easier to think in pixel units. I feel we have a 90 by 90 microns, 512 by 512. But if I look at one of these, these little things, I can say is 50 or 60 pixels or something around there. But this is going to be thousands, so I can quite easily throw in a number of 100 in pixel units and make sure we don't include those. Circularity, 1 being a circle, I think, 0 being a straight line. You can pick them based on their kind of shape too. I like to show something, and we can just overlay masks, let's say, and then we've got these options here. This will display the results. This will clear the results from the previous window, which is mostly useful, and then add to region of interest manager is of use too sometimes. So we'll go with that, and it's asking me if I want to save the previous ones because we're clearing it, so I'm not going to save those. Okay, so here's my region of interest manager. And run out of space for these little windows. And it's picked out the bigger objects and ignored the smaller ones, so we've done a good job there. We don't want the ones on the edges, so let's do that again and see if we can use the option to exclude on edges, see how that does. And we won't save those measurements there. So wonderful, it's picked out the cells we want and excluded the ones on the edges. We could have equally excluded them based on size and just kept them that way. And here's results, and we've got 4 cells, and these are the areas of each cell. And so that's how you go around about counting, the basic counting of cells that way. And you can break it up into those steps, and you have to tweak it for your particular cell type, images, magnification, and things like that. But it's essentially the same thing. Let me know if you have any questions on how to set up and how to tweak it, and we'll go from there.